Hello, everyone. Let's get started again. Um, Last video, we discussed triple scalar product, and also we discussed the index notation of that triple scalar product. Today, in this video, we are going to extend our discussion further in uh, permutation symbols and Kronecker delta relationship. We are trying to find the relationship between epsilon and delta. To find this relationship, let me start with the second order tensor. Any second order tensor, we discuss if it is a second order, you need two free index. You can write it Aij. The vector notation is this one. The matrix notation in the books they use bold uppercase letter, right? We don't use the last one here, but we use these two in our discussion, right? Again, this is like a matrix. So let's say the Aij, I can consider like this, right? A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, right. So this is actually the matrix, right? So instead of writing matrix, we use this index notation. In your matrix algebra, you studied some of the row operations, right? So actually in the row operation, you studied three row operation. The first one, you can interchange any two rows. Okay. The second one, scalar multiplication. So that means let's say lambda into Ri. So one row, you can replace it by the multiplication row, right? The third one row, you can replace it to uh, the summation, right? The operation between two rows, right? Like this. Okay, so these are the three row operation. Here you must be careful. The Ri, the selected row, you don't multiply by anything, right? The next row only multiply and add, right? Okay. This is something you studied in matrix algebra, right? In this discussion, you also discuss these things, right? So when you switch these to row, let's say you will get one new matrix B. The determinant of this matrix will be negative of previous matrix. This is something you studied, right? So for example, in this case, let's say in this case you are getting determinant of B. The B matrix mean after row operation, you get that matrix. That matrix I called as a B, right? So in this case, it is lambda into determinant of A. In the last case, the determinant of B is equal to determinant of A. So these are the three things you studied in your matrix algebra, right? Because I'm not going to waste my time to derive these things. Then here, we are going to discuss the first one, right? This derivation. But in this case, I'm not using the same method you studied in your matrix algebra. That here, I'm going to use a different method. That means our index notation method, right? Okay. Uh, Let me write a B matrix, right? Matrix B, the first case, right? The first case, what I'm going to consider now, I'm going to switch between two rows, right? So that means B matrix I consider now. So I can write Bij, right? Okay, no problem. I'll write it B. So now I'm going to shift first two rows, right? Then here A21, A22, A23. This one A11, A12, A13. Third row will be the same, right? So this is the row operation you might have studied. Okay, so in this case, the determinant of B, just now we discussed minus determinant of A. Okay, right. So now I'm going to look at this one carefully, right? So that means if I take the first row and this one, right? I'll keep the second, this one is same, right? 2, 3. Only thing, the first subscript, I change it to 2, 1 to 2, 1 to 2. So that means now you can remember this one, right? This is something we studied, right? The permutation simple 1, 2, 3. Okay. Here 1 going 2, right? Similarly, the second one, if you take, you keep this one same, right? This will be 2, this will be 2, 3, 3, right? So now 2 to 1, right? 2 to 1, the opposite order, right? So therefore now I can connect this row operation with our permutation symbol. How I'm going to connect this one? So now I'm going to consider my B matrix this way, right? Let's say A, I'm going to switch the first one, right? I'll keep it A, M, M1, M2, M3, right? Here AN1, AN2, AN3. The last one also I'm changing now, right? R1, R2, R3. Right? If it is, this is my B matrix. Now determinant of B mean I am considering this one, right? Determinant of B is now my uh, determinant of B equal. How can I write this one? Now I don't write -1, right? Because why I don't write a -1? Because now I can switch again here, right? So it will become plus now, right? So what is this the first thing is doing when you switch the row, the previous determinant sign will change, right? So when I operate this one in multiple times, this will become -1 plus 1, -1 plus 1, right? So therefore it should follow this order, right? This order or opposite order. So therefore I can write this one this way, right? MNR determinant of A. Okay. Someone can ask me, okay, epsilon MNR, we also discussed 0, right? But in this case, you won't get that 0 case, 0 situation you won't get, right? Because always 1, 2, 2, 2 only. Always you will get, right? Always you will switch these two, right? So therefore you won't get that 0 situation here, right? Okay. Now this is the first case I am considering, right? Now second case, I can switch this one. I can apply this one also for the column, right? The same row operation you can apply for the column operation also, right? Okay, in the column operation, let's say now my B matrix. Okay, so now what I'm going to do, I'm going to shift this one, right? Instead of uh, 1, 2, I'm shifting the column now. That means from A matrix, I'm switching first to column, right? Now instead of 2, 1, this will be 1, 2, right? 1, 2. This is 2, 2. This is, I think, 3, 2, right? Yeah. Okay. Yes. So this one now, the first row, right? A1, 1, A1, 2, A3, 1. This will be same, right? A1, 3, A2, 3, A3, 3. Okay. So now what I'm doing here, I'll take different color now. Now I'll keep the this one, first subscript now, same, 2, 3. The second one I am shifting, right? Okay. The same thing is here. The first one I'll keep it same, 1, 1, 3. The second one I'm shifting. In this case also, the determinant will be negative, right? Determinant of B minus determinant of A. Okay. Now I'm going to connect this one with now the Kronecker, the permutation symbol, right? Okay. So now what I'm going to do, the first symbol I'm going to keep it same, A1, A2, A3. The second symbol I'm going to change, right? Okay. So this will be, now I'll keep 1P. I don't use M and R, I'll use different, right? 1Q, 1S, right? So this will 2P, 2Q, 2Q, 2S, right? 3P, 3Q, 3S. Okay. So now from here, determinant of B, now I can write. Now what is that? I'm going to use PQS, right? PQS, determinant of A. Okay, right. Now what I'm going to do, I'm going to combine these two together, right? So what I'm going to do now my B matrix I'm going to consider now AMP, right? AMQ, AMS, right? ANP, ANQ, ANS, ARP, ARQ, ARS. Now what is that? I have to apply for both subscript, right? Now determinant of P will be MNR PQS determinant of A. Okay, so this is very important properties for row operation and column operation. We are connecting both. Okay, right? So I have to apply the first one for the row operation, the second permutation symbol for the column operation, right? So based on the sign, the determinant is changed, right? This determinant of B you can calculate. Okay, right. So now let me copy this one. Okay. Right. So let me move to the next page. Okay, this one now. Now what I'm going to do now, I'm going to take A is, right? I also bring A, right? This is your A, right? Okay. Okay, I will write it. Everything is the same color. Okay, A11, 21, 31, 22. Right. So now Aij, I'll consider now Kronecker delta, delta Ij. So therefore now my A matrix become delta 1, 1, 1, 2, 1, 3. This is so I no need to write like okay, but delta 1, 2 is 0, right? So therefore it will be like identity matrix, right? Okay. So what is my B matrix now? Bij. A become delta, right? So therefore my B matrix delta MP, delta MQ, delta MS, right? Delta NP, delta NQ, delta NS, right? Delta RP, delta RQ, delta RS, right? Okay. So now we will apply this relationship here, right? Determinant of B mean this one, right? Determinant of B now, this determinant, right? So I will write right side first, right? M N R R Q S. Determinant of A, for identity matrix, it is 1, right? Okay, so this equal determinant of B mean this one, right? Okay, right? Okay, so this is the important relationship, very, very important relationship. This is a relationship between permutation simple and delta, right? Okay, how can you rate this simply, right? So for practicing, I'll change it different index, right? Instead of MRIJK, this is I'll consider now uh, LMN, right? How can you write easily? You see the first one, keep it first, MR, MQ, MS. Uh, this will be PQS, right? Okay, right? MP, MQ, MS, right? Yeah, it is PQS, right? Yeah, it's a typo, right? So now the first one, this will be IL, IL, IM, IN, right? Okay, so this will be now second one, JL, JM, JN, right? The third one, KL, KM, KN, right? Yeah. Okay. Right. So simply you can write, right? So now what I'm going to do, let's say you can write many things, right? So first one, you can write JK, IJK, right? So IJK. So now the last subscript of the previous one, the first subscript of second one, I am going to keep it same, right? In this case, what will be the answer? So what you have to do here, only thing you have to substitute L equal K, right? This will be IK, this will be IM, this will be IN, right? So this is JK, JM, JN, right? So now this will be AK. Delta II we already studied 3, right? So therefore delta KK will be 3, right? So I can put 3 here. Delta Km, delta Kn, right? Yeah. Now I can simplify this one, right? This determinant, delta Ik, right? The first row, these two, right? Delta Jm, delta Kn minus delta Jn, delta Km, right? Okay, minus the second one, right? Delta Im. So this will be these two, right? Delta uh, delta Im, this one, right? Delta Jk, right? Yeah. Delta Jk, delta Kn minus 3 delta Jn. Okay, right. The last one, delta In, here these two, right? Delta Jk, delta Km minus 3 delta Jm, right? Okay, right. Now I can simplify, right? Okay. How can I simplify, right? I'll do one thing, right? I need the place rather than moving to the next page because this is bit, complicated simplification. So I will write it here, right? Plus. Okay, right. So now delta Ik multiplying inside, right? I will write it delta Ik delta Kn. Then we already discussed the properties of delta, right? Remove this one, substitute within, right? So therefore delta Ik delta In, right? Sorry, not delta Ik, right? Delta In, when I multiply these two, delta Jm will be there, right? So that means delta I, delta In, right? Delta In and delta Jm, right? Okay. The second one, IKKM, therefore IM, right? So therefore delta JN, delta IM. What I am doing, replace K with M, right? That's all. Minus here, right? I'll keep delta IM same, JKJN, delta JN, right? Okay. Minus 3 delta IM, delta JN, right? So minus into minus plus now, not minus, right? Minus into minus plus, right? Okay. So here delta in jkkm gm, right? Minus 3 delta jm delta in. Okay. You can see here now delta in gm, right? 3 delta in gm, right? So plus in gm, right? Plus in, I will use different color, right? This one, right? So this one, right? I can write uh, minus delta in delta gm, right? Okay. So now these three, right? I'll use different color. This one, this one, this one, right? I can write delta im delta jn, right? Okay. So that means this is very important, right? So I will write in next page. This is actually this one, right? So that means delta ijk and delta kmn equal delta im delta jn minus delta in delta jm. Okay, but what we are doing here, just ignore this one, just combine another thing, right? Im jn minus in jm, right? Okay, first combining in order, then we combine opposite way, right? Okay. Similarly, you can write ijk jkn. You can write it this one, right? How can you write? Now the last two and first two is same, right? Just I'm going to use this one now, right? What I will do, okay? I will remove the, okay, I'll remove this one, right? Okay, for to change it this one, I'll do this way, right? Okay, right? Delta ijk. Okay, you know here jkn, right? So this is the order, right? So therefore jkn, if I write k first, right? Knj, right? Knj, because both will be the same value, right? Right. So now what I'm going to do, I can use this one because first digit, last digit same, right? First digit, last digit same, right? I can combine another thing. IM. That means IN, right? Delta IN, delta JJ, right? Minus. Now I can combine other way, right? IJ, delta IJ, delta J. Okay. Now delta JJ, 3, right? 3 delta IN minus IJJN. I'm going to apply the property. J is common, then you can write IN, right? Okay. Yeah, so now 3 IN minus IN, this will be 2 delta IN, right? Okay. Yes, I think this video a bit extended. Okay, it's fine, right? We discussed many important stuffs here, right? Please go through again because this will be the video, because this is very important part. We need this one. We will discuss these things in some of the derivation, right? Okay, so I'll stop at this point. If you have any doubts, then inform me into the comment section. Then I will look at it and then I will include in next videos, right? Thank you very much.